Let's take a look at this one. We did a question just like it, but we've simplified a part. It used to be squared like this, but that made it very intangible, which means it's like just hard to look at. Like I don't really know an answer. We got an answer. We knew it was yes. We just weren't able to really mentally prepare for it. So same concept, same type of question. We're looking for equivalency between two functions. So we're going to set them equal to each other. So f at x is equal to this. G at x is equal to this half. So we're going to set them equal to each other. All right, and we have a 72n. And the question is, are there values of n? So we're trying to isolate for n. Are there values of n that allow these to be equivalent? Okay. In this case, what I'm going to do is I'm going to move everything to one side. Okay, I don't have to deal with any squaring or anything, so let's just move everything over. We get 3x squared, I'll get positive 9x, and I'll get negative 10 minus 72, 72n. And on my right side, I'm set to 0. This looks a little more familiar. It kind of looks like a quadratic.
Yeah.
And if I write a quadratic in standard form, I go I got my x squared, great. I got a b value. On my x. My c value looks a little funny. And it turns out this whole thing is my c value. Okay? So we're trying to find equivalency between things. So what you're actually looking for values of n is you're looking for roots. And if you remember, to find roots, you can use like the quadratic formula.
Mm-hmm.
But this question doesn't ask us for the exact roots. It's not saying like when are they equal. It's just saying are they. So there's a more simplified version we can do, and we're looking for things. If they're asking are they, what they're asking for is if this is a quadratic, does this quadratic have roots? Does it have roots is the question. Because a quadratic could be something like this with no roots, or down like this and have no roots. It could be this where it has one single root where the vertex is touching, or it could have two here. We have, a tool. We have a tool to find roots. It's called the discriminant. Do you recall that, the discriminant at all? It's written like this. It'll say b squared minus 4ac, which is a part of the quadratic formula. It's the part that like lives under the root. And it says if this value is less than 0, there are 0 roots. Okay? If this is equal to 0, there's 1 root, which would mean there's a root. And if this is greater than 0, then we have 2 roots. Okay? And we'll kind of color code it here. We'll draw this yellows up to there. 1 root goes to there. And 0 roots looks like that. And that's what it's asking. Does it have 0 roots or does it have roots? Could be 1, could be 2, doesn't really matter. So in other words, what we can do is we've related it back to our A, B, and C. We can now use this little formula to find out are there roots. So that's what we're going to do to solve this. So we're looking for this scenario here. Is this number less than 0? So we're going to set it up as an inequality. 0 is greater than 2, and then we're going to sub in B. So my B value happened to be 9. So 9 squared minus 4. My A value happened to be 13. And my C value, my C value is pretty big. I'll write it out like this, negative 10 minus 72n, okay? Still a tricky question, so we're gonna work our way through it. This becomes 81, negative 13. Negative 4 times 13, what are we gonna get here? 52, so we get negative 52. And that we have to distribute into this C value here. I'll need your help probably with like the 72 part there at one point. This will become plus 520. This will become positive something. I don't know what the heck it's going to be. It's going to be positive something though. You want to do that part without a calculator for me?
3,744.
3,744 n. Okay. Let's get our like terms together here. We got 81 plus that. 81 plus that will give us 601. So 601 plus this huge coefficient of n. I'm going to move this to the other side. Okay. And it turns out if I move this to the other side here, we get Negative 601 greater than 3,744. N, I'm still trying to isolate for n. Now with inequalities, if you multiply or divide by a negative, you have to switch the sign. On this side, we're going to divide, but it's not by a negative, so the sign itself is going to stay the same. I don't know what this value is. We'll turn it to a decimal so it's a little more tangible. 1. You want to find out what 601 divided by 3,744 is? We'll say it's approximately something. Negative something.
It doesn't even give me a decimal.
601 divided by 3,744? Oh, you have a mode. Shoot. You have a way of switching on your calculator. What the heck is it? Got a good calculator. I just never had a great one like this, so I never remember how they worked. There's a button we push and we switch between. Here it is. See this button says change?
Yeah.
There you go. What do we get? 0.16?
Yeah.
Awesome. Negative 0.16. So what this says is, yes, if n is less than approximately negative 0.16, there are 0 roots. Which means if n is greater than negative 0.16, then we have roots. Yes, roots. 1 or 2 roots. And that's what we found in the other one. There are roots to it. This one's giving us an inequality. It only exists if n is some certain value. And we could kind of try to graph this relationship. I'll quickly graph it on, we got decimals up again? Yeah, we do. Let's turn these two off. I'll show it to you. What we're going to do is I'm going to type in the quadratic we had with the letter n, which was this one here. So I'm going to put in, it was 13x squared plus 9x minus 10 minus 72n. Okay, so this represents a quadratic, and if I bring it lower, here we go. This value, negative 0.3, is less than negative 0.16. If you remember, that was our answer. I should probably write it on here because that's going to be hard for us to remember. But it said if n is less than negative 0.16, approximately, it's not quite that, there are 0 roots. Oh my gosh, that's not how you write roots. Try to write with a mouse, I'm not as good at this. There we go. So when we take a look at this, n is less than that, you'll notice the quadratic goes higher and higher. There are no roots when n is that. But as soon as we get down to it, get close to it, here, that's a little less. And then as soon as we go over it, there's some roots. They exist. And if I even went a little closer and I do like between here and 1, let's see our steps. There we can get even more refined. There we go. That's when it has 1 root. Anything higher, there are no roots. Anything lower, yeah, lots of roots to this question. A little more palatable, this question, than the other one that you dealt with, okay?